Section 2.1, we're going to look at graphs. What you see here is a coordinate system. It's made up of a horizontal line, which we usually call the x-axis, and a vertical line, which we call the y-axis. We don't always call them x and y. Sometimes we use other variables or other names, but these are the most common names. These lines divide up the coordinate plane into 4 regions, and these 4 regions are called quadrants. And so we start here with quadrant 1, and we move counterclockwise all the way to quadrant 4. And the reason we start in this quadrant, the reason this is the first quadrant, is because in this quadrant, all points have a positive x-coordinate and a positive y-coordinate. When you move to the other quadrants, at least one of the coordinates is negative. And we'll talk more about actually graphing points in just a minute. So this system is often called a Cartesian coordinate system or a rectangular coordinate system. And sometimes people just refer to this as the XY axis. The main purpose is that this is used to locate points in the plane, which we call two-dimensional space. Let's graph some points. Actually, one more thing I forgot to mention. The point in the center here, where the two axes meet, is called the origin. Okay, let's graph some points. So when graphing points, you need to understand that the first coordinate given corresponds to the x-coordinate or the horizontal coordinate, and the second coordinate given corresponds to the y-coordinate or the vertical coordinate. And so it's helpful to remember to label your axes. So this is the x-axis here, and this is the y-axis here. Oftentimes when we're graphing points, we will give them names that are capital letters, just for simplicity. And so when we want to graph the point 2, 5, 2 means that we go to the x-axis and we locate the number 2, which should be right here. And then 5 on the y-axis is up here. And if you line up x equals 2 and y equals 5, you get this point. And this is point A. And we can do that for all of these points. So let's go ahead and run through this. Point B has an x-coordinate of -3 and a y-coordinate of +4. And so point B is located here. And we don't have to label every point that we're going to graph on the x and y axis. And so what I mean is, here we can just count. So we know this is -1, -2, -3. It's not necessary to actually put -3 next to the axis there. Same thing goes for +4 up here. So actually, let me take that out because all that does is just kind of clutters my graph here. Okay, let's go ahead and graph the point C. C has coordinates -5, -4. So x equals -5 is here, and y equals -4 is down here. And so point C is at this location. Point D has coordinates +3 and -8. So x equals +3 is here. Y equals -8 is down here. And so we can locate that point as being right here, and that is point D. Point E is a little different. Point E has an x-coordinate of 4, which is here, and the y-coordinate is 0. And so if the y-coordinate is 0, that means we don't go up or down. We just stay on the x-axis. And so here is point E. Point F is similar. Point F has an x-coordinate of -5, and a y coordinate of 0, and so it is also on the x-axis. Point G is 0, -6, which is x equals 0, means we don't go left or right, but y equals -6 means that we drop down to this point. And finally, point H. Point H, of course, is the origin, has coordinates 0, 0, and that is the point right in the middle here. So those are some graphing basics, which, if I had to guess, I would say most of you have probably done this before. So next we have an application of a graph. So it says this graph represents the height of a rocket on the vertical axis. So this axis here represents the height of a rocket, and time on the horizontal axis. And so the horizontal axis here represents time. And it says this. So basically a rocket has been launched into the air and time is ticking by here in seconds. And the height of the rocket in feet is given by this graph. And so here we have some coordinates. So when time is 0, the height of the rocket is 0. After 1 second, the height of the rocket is 80 feet. After 2 seconds, it's 128 feet, etc. And so a couple of questions pertaining to this graph down below here. What is the maximum height of the rocket? So the maximum height would be the highest point that is attained by the rocket. That is this point right here. Now we want to know, what is that? Now notice when you look at the graph, it's not obvious exactly what that height is. It appears to be a number between 140 and 160. So graphs don't always give you precise answers. Even if we zoom in, it's not a precise answer. So we really need to rely on tables or equations to give us precise answer. Now, thankfully, we can see that that maximum height seems to occur when x equals 3. And we know that when x equals 3, y equals 144. So the maximum height of the rocket is 144 feet. And I'm not getting that completely from the graph. I used the table in conjunction with the graph to answer that question. When does it occur? Well, when the maximum height occurs refers to time. Well, we can see down here it occurs at 3 seconds, and we can also see that here in the table. So when do we reach the maximum height? 3 seconds after the rocket was launched. And the last question, when is the height of the rocket 40 feet? So for this, I'm going to zoom in a little bit here. And I'm going to take note of the fact that 40 feet is right here. And we can see that the rocket passes 40 feet on the way up, and it also passes 40 feet on the way back down. And on the way up, it appears to do it at somewhere in between 0 and 1 second. And we'll say that it's approximately 0.5 seconds. And on the way down, it seems to cross 40 feet again at approximately this value, which seems to be about 5.5 seconds. And so we can use graphs to help us get information about a situation. And they can help us be a little bit more intuitive about that situation. So graphs are not designed to make our lives harder. They're actually designed to make our lives easier. And so down here at the bottom, we're going to answer this question. We're going to say approximately 0.5 seconds and 5.5 seconds. And understand, this is just an approximation. One final concept in this section is the concept of a midpoint. And so let's suppose we have a line segment from point P to point Q. And let's suppose that point P has coordinates x1, y1. Let me write that down a little bit larger. So point P has an x coordinate of x1 and a y coordinate of y1. Point Q has an x coordinate of x2 and a y coordinate of y2. And this is called subscript notation. And we use it frequently to represent points where we don't actually know the coordinates. So the midpoint of this line segment is the point on the line segment that is exactly in the middle of point P and point Q. And the midpoint has a formula where all you need to do is take the average of the x coordinates to get the x coordinate of the midpoint, and then take the average of the y coordinates to get the y coordinate of the midpoint. And so the coordinates for the midpoint are given by the following formula. X coordinate is x1 plus x2 divided by 2, and the y coordinate is y1 plus y2 divided by 2. So all we're doing is adding the x coordinates of the endpoints and dividing by 2, and adding the y coordinates of the endpoints and dividing by 2. And sometimes you'll see this referred to in the following way. The midpoint will often be labeled as xm and ym. And we can rewrite the formula as the x coordinate of the midpoint is this, and the y coordinate of the midpoint is this. So all we're talking about here is some notation. Okay, so let's look at a quick example. Find the midpoint of the segment through P and Q where P has coordinates -3, 8, and Q has coordinates 7, -1. And so to do this, I need both the x and the y coordinates. So we know the x coordinate of the midpoint is x1 plus x2 divided by 2. And the x coordinates, x1 and x2, are these two numbers. And so we only need to add those together and divide by 2. And this gives us the x coordinate of the midpoint is 2. For the y coordinate, we do the same thing, but we add the y coordinates and divide by 2. And the y coordinates are here and here. And so this is going to be 8 plus -1 divided by 2, 7 divided by 2. And we'll just leave it like that. And so the midpoint is the point 2, 7 over 2. And that's how we can write that answer. Now, in a slightly different example down below here, let's suppose we know that line segment PQ has a midpoint M, and we know the coordinate of the midpoint is -1 and 6, and we know one of the endpoints is 5, -3. And now I'm asking, what are the endpoints, what are the coordinates, rather, of the other endpoint, Q? Okay, so once again, what do we know in this problem? Well, we know that our midpoint, we'll call that M, has coordinates -1, 6. We know that P has coordinates 5, -3. We do not know the coordinates of Q. Now, you could just call the coordinates of Q x and y. Or if you wanted to be consistent with the notation that we used earlier, you could say that it's x2 and y2. But there's really no reason to use the subscripts here because it's the only x and y that we don't know. So it's up to you if you'd like to use the subscripts for this. That's what subscripts are for, right? subscripts are to distinguish between the two different points. Okay, so what we can say here is, first of all, we know that xm equals x1 plus x2 divided by 2. And what is the x-coordinate of the midpoint, right? What is xm? Well, it's -1. So we can put that in here. And then what is x1? Well, x1 is the x-coordinate of point P, which is 5. And x2, well, x2 is the x-coordinate of Q, which we don't know. So we're just going to call that x, and then divided by 2. And now what we need to do is solve for x. So what I can do to both sides is I can multiply by 2. Doing that gives us -2 equals 5 plus x, because here the 2's cancel. And then if we subtract 5 from both sides, we get -7 is equal to x. So this is the x-coordinate of Q. To get the y-coordinate of Q, we do the same thing. So we know the y-coordinate is y1 plus y2 divided by 2. The y-coordinate of the midpoint is 6. The y-coordinate of point P is -3. The y-coordinate of point Q is unknown. And then we solve the same way, multiplying both sides by 2 and doing the math. And so we now have our x-coordinate and our y-coordinate for point Q. And so we'll say point Q has coordinates -7, +15. Okay, let's go ahead and move on to section 2.2. In section 2.2, we're going to begin to look at graphing linear equations in two variables. Now, I put down an example of a linear equation in two variables. It's an equation that typically relates the variables x and y to each other. And what's really important here is both x and y are being raised to the first power. That's what makes an equation linear. You cannot have any powers other than 1. Now, if I want to graph this equation or graph the solutions to this equation, what we can do is we can make a table of values. These are x-coordinates and y-coordinates. And we can find some points that correspond to one another. Now, technically, you can pick any values that you want for x, and then you can find the corresponding value of y. Notice that y is equal to 1/3 times x. I'm going to pick values of x that make this computation a little bit simpler. I'm going to pick x equals -6, -3, 0, 3, and 6. And the reason I'm picking those is because when you multiply those x values by 1/3, you get a whole number. So let's just look at an example, and then I will fill in the rest of the table. So when x equals -6, y will equal 1/3 multiplied by -6, and then -2. 1/3 times -6 is -2, and then -2 is -4. So when x is -6, y is -4. And we can see that that point, -6, -4, is right here on the graph. Notice that that's x equals -6 and y equals -4. Now, if you do that for the rest of these points in the table, you can find the corresponding y values. And so when you plug in -3, you will get -3. X equals 0 gives us y equals -2. X equals 3 gives us y equals -1. And x equals 6 will give us y equals 0. And if you plot these points carefully on the graph, you will see that we get all of these points that I'm sketching now. So if I label these as point A, B, C, D, and E, you can see that these are the points A, B, C, D, and E. And that's precisely the point. When you have an equation and you find a solution, the solution is an ordered pair, an x value and a y value that go together that make the equation true. So all of these points in this table make the equation true, and therefore that is why they are on the graph. And you'll notice that the graph is a line. Furthermore, any point that is on the graph must make the equation true. So for example, if you just notice on this graph here, this point is on the line. And that's the point x equals 9, y equals 1. If you plug that into this equation, you will get a true statement. Let's just observe this. So if we take the point 9, 1 and plug it into the equation, this gives us y, which is 1, is equal to 1/3 times x is 9, minus 2. And if you do the math, you get 1/3 1 equals 1/3 times 9 is 3 minus 2. And this says that 1 is equal to 1. So it checks out. So again, every set of coordinates that makes the equation true will be on the graph, and every point that is on the graph will make the equation true. So when you're graphing a line, for example, you're not just drawing a picture, you're looking at the picture of the solutions to that equation. So the next concept here is, what does it mean to be a standard form of a linear equation? Now, the standard form of a linear equation is when it is written like this: ax plus by is equal to c. And you'll notice on the previous page here, this equation was not in standard form. It was in a different type of format, which we'll talk about later. So an example of something that is in standard form might be something like this equation here. 5x minus 4y is equal to 20. Notice that a in this problem is 5, b is negative 4, and c is 20. Now, what's nice about standard form is that you can find the intercepts of the line. Now, the y-intercept of the line is where it crosses the y-axis, and the x-intercept of the line is where it crosses the x-axis. And if we just go back to our previous example, you'll notice that the y-intercept for this line was here. So the y-intercept is the point 0, negative 2. And the x-intercept is here. And the x-intercept is the point 6, 0. So one thing you should notice is that when you're finding the y-intercept, x equals 0. And when you're finding the x-intercept, y equals 0. And in fact, this is stated here. So the y-intercept is the point 0b. To find b, substitute 0 for x in the equation and then solve for y. And likewise for x. So if we use this equation as an example, let's go ahead and talk about how we would find the x-intercept of that equation and how we would find the y-intercept of that equation. And so the rule says to find the x-intercept, we're going to let y equal 0. So if you plug y equals 0 into this equation here, you end up getting 5 times x minus 4 times 0 is equal to 20. And that is 5x equals 20. And if you divide by 5, you get x equals 4. To find the y-intercept, we basically do the same thing, except that now we let x equal 0. plug it into the equation. That's 5 times 0 minus 4 times y equals 20, which is the same as negative 4 equals 20. And if you divide by negative 4, you get y equals negative 5. Now what this allows us to do is it allows us to graph this line very quickly and very easily. So let me import a graph here. So we have an x-intercept of x equals 4. Please keep in mind that that means the point itself would actually be x equals 4, y equals 0. And that point is right here on the graph. And then for the y-intercept, we have y equals negative 5. And also keep in mind that means the point is 0, negative 5, which is this point down here. And then to graph the line, all we need to do is sketch a line going through those points. And so if we do that, we should get something like this. So sketching a line from standard form is relatively simple, and that's one of the reasons why we talk about standard form. So let's take a look at one more example. Suppose I want you to graph this line, which is in standard form. So let's go ahead and get the x and y intercepts. So to get the x-intercept, we let y equal 0. And if you let y equal 0, you get 6x equals 30. You see what happened there? If we let y equal 0, this term goes away, cancels out when you plug in 0 here. And so if 6x equals 30, that means x equals 5. And to find the y-intercept, we simply let x equal 0. And if you let x equal 0, you get 5y equals 30, and that means that y equals 6. And so we can quickly and easily see that x equals 5 and y equals 6 are the x and y intercepts of this line. And that allows us to sketch a graph with relative ease. Okay, one last concept we need to discuss is the equations of horizontal and vertical lines. So a horizontal line is a line that is flat. And for a horizontal line, it has the equation y equals b, where b is the y-intercept of the graph. Now the reason for this is really simple. Every point on a horizontal line has the same y value, and it can have any x value you would like it to have, but y is always going to be the same. For a vertical line, it's just the opposite. A vertical line has the equation x equals a number, for the same reason. On a vertical line, x is always the same x coordinate, but the y coordinate can be anything you want it to be. Now, as a special case of this, if I talk about the horizontal line y equals 0, that line is actually the x-axis. And the vertical line x equals 0 is actually the y-axis. Now, just to make sure we understand this completely, let's do a simple example. Let's graph the lines y equals negative 5 and x equals positive 2. And to do this, we'll bring a graph into the picture. And so to graph y equals negative 5, we know that's a horizontal line, so it has to go this way, and it has to cross the y-axis at negative 5, which is down here. So y equals negative 5 will be a line that looks like this. X equals positive 2 will be a vertical line, and it'll cross the x-axis at x equals 2, which is right here. And so the line x equals 2 will look like this. Okay, time for you to get some practice. That's it for sections 2.1 and 2.2.